everybody, I'm Ross, and welcome to our Big Tuna and Unagi live demo. I'll be working as your moderator and making sure that all of your questions get answered. If you do have any questions, please go ahead and punch them into that Q&A window you see on Zoom. That way we can get to those questions and answer them after we wrap up the live demo. Just in case we run out of time, it'd be really helpful if you make sure that when you submit questions, you have your name. Please don't submit them anonymously. That way, if we do run out of time and we still want to answer your questions, and we can email you after the live demo is over. Great. So with that, I'd like to introduce our demoer, Delray Jackson, who is our marketing manager for Buffer Exchange here at Unchained Labs. And he's going to be showing us how to use Unagi and Big Tuna to do buffer exchange and concentration, and maybe talking about some of the similarities and differences between the two instruments. All right, does that all sound about right to you, Del?
Sounds like a great setup, Ross. Thank you very much.
All right, great. So I'll be back in a little bit to do the Q&A, and yeah, have fun.
Fantastic. I'll try. So hi, everyone. Glad you could join us today. If you're here, most likely you're probably dealing with some biologics or gene therapy biomolecule and probably understand the importance of buffer exchange and sample concentration for them. Now, each of them can have their different challenges. If you're dealing with proteins, for instance, monoclonal antibodies, perhaps you need to do buffer exchange for very many samples at one time. Perhaps you're doing discovery or some sort of formulation development. And if you're working with a vector, such as AAV, a viral vector, what's really critical is needing to concentrate that to your specific target value. LNPs, lipid nanoparticles, very hot vector right now. It's very critical to do buffer exchange on them so that you can remove the organic phase, the ethanol, very quickly so that you can avoid that pesky size change that can come with it. And so today, what we're here to show is that with all of these challenges, what you have is typically the need to do this very quickly and to save you manual time. And that's why it's really fun to be here today to get to talk to you about not just one, but two solutions that we have for you that has our proprietary buffer exchange technology, which we refer to as positive pressure-based ultrafiltration diafiltration. And so that's something that both of these platforms, Unagi on my left, Big Tuna on my right, have in common, is the way that we do buffer exchange is a really cool technology piece. We essentially use, as you'll see in a moment, spoiler alert, the buffer exchange chamber. We are able to apply even positive pressure across all samples, whether you have one or up to 96 of them at the same time. And while we do that, we can also gently mix them, which is really cool because it gives you results even faster, but also higher recovery as well. Because some of those other techniques where you can do buffer exchange and sample concentration, they suffer from gumming up or build up at the membrane interface. And as you'll see, our technology doesn't have that challenge. And so instead, what you have is an ultrafiltration, diafiltration, buffer exchange solution, and that's what unites both of them. And where are they different? That might be the other reason you're logging in today. You've heard of Unagi, you've heard of Big Tuna, but really, what's the difference between both of them? And that's something we're going to get into right now. We're going to discuss the consumable, look at the hardware a little bit, jump over to my favorite, the software, and then finally see both of these instruments in action. So with that, I like to always start with the consumables, right? That's where the magic happens. And so these consumables that you see in my hand are for the Big Tuna on my right. Big Tuna is our high-throughput automated buffer exchange and concentration solution. As such, it's plate-based. And so these unfilters are really filter plates, as you can see on the bottom here, which use regenerated cellulose membrane. They come in various molecular weight cutoffs, starting at 3 to 10, 30, and then 100. And it comes in two different volume and format size. And spoiler alert, that's really the primary difference between Unagi and Big Tuna, is the capacity of your samples. And sample capacity can be thought of in a few different ways. It could be your number of samples, so 96 here, or the volume of your samples. And so with the unfiltered 96, your samples can be in a working volume range from 100 microliters all the way up to 450 microliters. And for the unfiltered 24, you can work from 450 microliters all the way up to 8 mils. So that's really where your samples start with, and they're very easy to use. We won't show you that here. This is kind of an easy bake cooking show type demo, but essentially you can prep them with your buffer of choice or DI water or something like that, let them sit for a few minutes, and then they're ready for your samples to be put in there. So I'll show you that in a moment. But first, I'd like to switch over to the Una, which is the consumable for the Unagi platform. Unagi is really the benchtop buffer exchange solution. So it still has that same cool core technology piece. It just has a lower capacity. And what is that capacity? Well, you can run from 1 to 8 Unas, as you see here in the sample rack. This is nice. I like this feature a lot because you might be working at your bench, perhaps down the hall. You can kind of, again, prep your Unas for use and then load your samples into them. But instead of trying to carry all those things down the hall, unless you're a juggler like my colleague Ross, instead you can just put them right into the sample rack and carry them on their way. So you have up to 8, so you can run 1 or any number all the way up to 8. If you have less than 8, you can use these caps to plug any of the open positions. And your volume capacity range on a Una is 0.5 ml all the way up to 8 mils. So I'll just set that right in there. So there you go. Spoiler alert, we're going to talk about the rest of the demo. Now you know that capacity is the main difference between the two platforms. But let's go into details. I want to take you through the hardware first on Big Tuna and then Unagi to see specifically how those differences look. So here, hopefully Jeff, our videographer magician, is showing you perhaps a top-down view. I'll try not to wave my arms around too much. But essentially what you see here is Big Tuna from above. It's a buffer exchange solution, as mentioned. You can think of it as a liquid handler that is designed specifically to be able to do buffer exchange. And so this is where the magic happens. This is the buffer exchange chamber. It's identical to the one that you will find on the Unagi. And that is where, I'll just place it in there now so I don't forget it, your unfilter goes. Now, one thing I had left out that both Unagi and Big Tuna have is that they do volume measurement on a sample-by-sample basis. And we'll see this in action in a little bit, but essentially this ultrasonic volume sensor is picked up, and at the beginning of a run and in every single buffer exchange cycle, the exact volume of every single sample is tracked. And that's really cool because now Big Tuna and Unagi both know how to modulate the amount of time that pressure is applied. And the pressure that we apply is at 15, 30, or 60 psi, so more pressure usually means more force, and so that can control like how fast your exchange or your sample concentration will happen. I'll show you in the software part some of the other features that go into that to drive your overall buffer exchange process. Then there are up to 8 different reservoirs here. We kind of have a nice little showcase giving you an idea of how many of those that you have. And Big Tuna being high throughput, if you're able to see on this side of the screen over here where my hand is, the tip rack hotel. That is where you can store all of the tips. And the transfers that happen is really adding new buffer. If you're doing buffer exchange, or if you're running one of our concentration applications, which we'll see, reduce sample volume, that's the only time that we are transferring sample to the unfilter as well. So you'll see it in action a little bit later, but here is the arm. The gripper is on the right side. That picks up the ultrasonic volume sensor. And then you have 6 channels on the other side of the arm that do all of the aspirations and dispenses that Big Tuna needs. So there's the big boy, Big Tuna. Let's switch over to Unagi's, everybody's favorite benchtop buffer exchange solution. Here, I'll just go ahead, because I'm forgetful, place the sample rack in there, twist it in, pretty easy. And again, this is the buffer exchange chamber, that same technology. So this is where 15, 30, and 60 psi pressure will be applied. The other aspect of this, I mentioned it briefly earlier, you can't really see it in a demo, but it's that we do have a orbital mixer at the bottom. And that's one of those things that you're able to modify or to program or use one of our preset settings that's tailored for specific biomolecules. And again, that orbital mixing, that happens when the buffer exchange chamber door is shut and it's pressurizing. That keeps your biomolecules of interest off that membrane interface and up in solution, giving you, again, faster exchange as well as a higher sample recovery. Unagi being lower capacity, the buffer reservoir is actually in a 50 mil conical tube. If we want to throw out a name brand, your Falcon tube, but really any 50 mil conical tube that fits that dimension will work. I don't want to mess anything up, but it too also has a buffer rack, so if you want to prepare those buffers at your bench, easy peasy, you're able to transfer it back to the Unagi. And just on Big Tuna, disposable tips are used, 1 mil in this case. We don't have as much capacity need. And again, in action, hopefully then you'll see that pipette and or the ultrasonic volume sensor, which is located on the arm right here to the right. So there, quick overview of the hardware, and then while I run over here and hopefully not trip on anything, I will fire up our software demo to give you an idea of the other side of the instrument. So having worked in robotics with lab automation, I often think of these products as having really, two sides, one being the software, one being the hardware. So for Big Tuna, you can see here though, this isn't really like your typical perhaps automation software. This is really a buffer exchange software interface. So again, you don't have to know automation to use either of these instruments, even the high throughput Big Tuna solution as well. So unfortunately, due to time, I can't go into all of these details, but just to walk you through, give you a quick idea, I will set up a quick experiment. What's a good experiment name, Ross?
Banana.
Banana. All right, so here you can apply your experiment name, and then at a glance, you can see that you can do a buffer exchange, of course, and the option to concentrate that sample right after you do buffer exchange. Alternatively, you can also just run a concentrate only application, which will just bring your samples down. And then reduce sample volume, don't let the name throw you. Essentially what that refers to is that you can also do a sample concentration, but from a much higher starting volume. And as you can see, that's limited to the unfiltered 24, which for the purposes of today's demo is exactly what we're going to be doing. So I will click next. Here you have your reagents. You have a few different options. You can import a sample list. So here I'll just pull some in from an unfiltered 24 and also import a buffers list. Now that's optional. You can also enter this. Oops, I think that's too many buffers right there. So let me go ahead and delete some of these. The fun of a live demo, but I got to show off how easy it is to use the software. So yes, either import your samples and or your buffers. Here you have the option, as you can see, the samples are already mapped to the different wells, and so I'll just show off the software here for you, how you can select different columns, different rows. You can also select individual wells if you wanted to. And then once you highlight where you want it to go, you simply drag over your buffers. And a nice feature here, if you had been watching, in the bottom right, the next button highlighted. It doesn't do that until everything on each screen, you can kind of see the pit stops on top. Until that section is validated, the operator, you, are unable to go to the next step. Here's another really cool thing, is it shows you the reservoir for your setup. And so here, for the application that we selected, it's the sample source reservoirs are going to come from on deck. And then you don't have to know exactly like what type of lab you have or where you have to place it. You can just say like which sort of reservoir you want to use. And here, again, it's all pretty much accessible, easy to see and use software. And so here you can see these preset values that we were talking about. And I had mentioned that those preset values just set a few things. One is the recommended pressure level. One is the mixing speed and how often we're going to mix at, and then how much we're removing per cycle. But all of this is programmable. It's something that you're able to change to suit your specific biomolecules. Then from there, I jumped over it, but that's the shopping list that shows operators exactly how to set up their buffer reservoirs and their samples. And then once they bring it over to Big Tuna, they're able to get this nice overhead graphical view on how to do that. So that's Big Tuna, high throughput, the ability to import lists. Those are probably, really the main difference between the Unagi software, which I'll show you here right away. And I'll show you how easy it is to set up a buffer exchange and concentrate, and let's do it for proteins of a low concentration value. Here you simply select the number of samples that you have, we'll say 7, and for the UNA you have currently a 10, 30, and 100 kilodalton cutoff, again, in that regenerated cellulose membrane. And we'll go ahead and push forward. Unagi software is slightly different from Big Tuna in that it pre-generates more things. And so here it just comes up with generic sounding names, sample 1, sample 2, buffer 1, buffer 2. But you're able to come in and overwrite this. And so you can have, 1 to 8 samples and 1 to 8 buffers. And so perhaps you have 8 samples, you want to use 4 different buffers, you're able to do all of that here. You just would simply kind of back up and use the same buffer name, and Unagi will know that they're coming from the same source. Go ahead and click next. You can see how easy it is to set the initial volume. So since we're applying positive pressure over all the samples at once in that buffer exchange chamber, there is the requirement to have the same starting volume. Question we get many times is, do you have to have the same concentration? And I like to advise that it should be within range. So now I will just go ahead and select the next final volume as we prepare to, after this, we're going to walk over to the Big Tuna and see it running. And here is the target exchange value you can set. So I will go ahead and do that. And then similarly, you have this graphical interface for operators to set up. So I think I gave you the highlights, hopefully enough for you to see the differences in the software. Now let's go over and see this running in action. Here, Big Tuna. Thank you, Dr. Ross, for the assists getting this started. What you're seeing here is that volume measurement that happens at the beginning of the run. And this is a very key part of this solution. This isn't something that you're going to find in many other platforms. And right now, the volume sensor is actually measuring the 4 corners of the plate. It does that to make sure that it's in perfect alignment, which it's seated in there pretty well. So through mixing cycles and whatnot, it does stay seated. But in the off chance it moves, this sort of calibration of the different 4 corners is done. And then it will go through using that ultrasonic volume sensor, which has about up to a 10% accuracy specification. And it will measure that sample volume of each one. Again, how is that information used by Big Tuna? Well, essentially, it adapts the positive pressure, the amount of time that positive pressure is applied in every single buffer exchange cycle. And the reason for that is your sample integrity is prioritized. So what that means is you might have a mixture of slow and fast running samples due to minor variations in concentration or perhaps formulation differences. This volume measurement makes sure that those fastest flowing samples are not going to be dried out. And so next step, I'll let you watch this. It should go over, closes the buffer exchange chamber door, and then applies that pressure there. And the next step would be to grab the tips. And I just realized that I forgot to push, apologies, start on Unagi. So let's go over to Unagi here, switching it. Again, by this point, hopefully you're familiar with the pieces that are very similar, that buffer exchange chamber, the orbital mixer that happens, and the volume measurement. So for Unagi, again, its reservoirs, its buffer reservoirs are contained in these Falcon tubes. And I don't know if you're quite able to see, but now that orbital mixer is mixing all of our UNAs that are in that sample rack. And then it's going to come over, grab a tip, and with this single 1 mil tip, using air displaced pipetting technology, it's going to be able to do the buffer additions for you. And so with that, hopefully you have a nice idea that you have 2 options, not 1, but 2 options to take advantage of our adaptive positive pressure ultrafiltration diafiltration technology so that you can save not just time, but also achieve superior sample recovery results. So thank you very much for your patience and for your attention. And with that, I'll turn it over to my colleague, Dr. Ross.
Cool, so thanks for that demo. That went really well, I think, Del. And so it looks like we've got a bunch of questions that have come in through the chat. So you ready to get started on the Q&A?
I am, thank you, Ross.
All right, fantastic. So first question is, do I need an air hookup to run these?
Oh, yeah. Apologies, I probably glossed it over. But yes, the buffer exchange chamber, which applies that positive pressure, that comes from air. Typically, CDA, clean, dry air, is enough. So if you have house air or a drop, you can do that. And we have a few customers who will put a compressor, mainly for the Unagi for some reason, that seems to be a little bit more common, but they'll just have a small compressor that provides the air needed.
Cool. All right, great, thanks. So then next question. What happens if I run out of tips?
Right, yeah, so high throughput on Big Tuna, lots of tips needed, of course. And then Unagi, less tips, but good question, I suppose. If it happens on either instrument, the instrument will pause and you'll get a notice sent to you. If you have the Unagi configured, that notice can come on your mobile device.
Cool, that sounds like a super useful feature.
Yeah.
All right, next question. How different can sample concentrations be in a single run?
Yeah, good. That's a good question. I don't want to get into too much detail, but really what it comes down to is the flow rate, right? And so you can have different flow rates because of changes, again, in concentration or in your formulation, and that's important. I would say it should be in the same neighborhood, if that makes sense. And I know I didn't focus too much on it, but you see an idea of that in the preset sample templates where we have like less than 0.5 and then 0.5, I think up to 10 mgs per mil. So they don't have to be right on the dot, but they should be fairly close. And in the end, what matters is how their flow rates are going to happen. So do you have to have exact concentrations between all samples? No, but they should be close so that their flow rates are fairly uniform. Now, if there's a case where that's not going to happen, keep in mind, Big Tuna and Unagi prioritize your sample recovery or making sure that your samples are not lost. So the worst thing that will happen is it will run long, and something I forgot to mention is there is a feature on both instruments where you can pause your run when some of those samples are done, and then those faster flowing samples take them out, and then the overall run will finish quicker.
Oh, okay, cool. All right. All right, so the next one that we've got here is, can I put Unagi in a cold room?
I mean, physically, yes, but no, we don't recommend that. It's not supported. So I know that there's a lot of questions around this about, well, I have samples and I want to run them cold. We don't support that on either instrument. It can affect the electronics for this with condensation and whatnot. But I do want to put a reminder, the person asking that question is probably concerned of like keeping their stuff at room temperature. But keep in mind that many of these runs can be fairly quick, like less than an hour. Otherwise, they'll process fairly quickly. And if you were to chill it and cool it down, it would take even longer to run.
Oh, that's a good point. Okay. What if I enter the wrong volume for a sample? I'm sure everybody's made a mistake on software before like that.
Yeah.
So what happens?
Yes. So if you either enter the wrong volume that you didn't pipette in there, or perhaps you made a mistake, you didn't pipette enough volume, I would like to say that it's all going to be relative. So both Big Tuna and Unagi are going to measure that initial volume, and that kind of becomes the reference point, if you will, for every single buffer exchange run. So let's say you entered like 10% less than actually was pipetted in there. The final volumes reported in both software would be off by 10%, but it doesn't mean that, oh no, like it's going to dry out or lose a sample. It sort of normalizes to what's actually read by that ultrasonic sensor.
I see. Okay, that makes a lot of sense. Okay. All right. What kind of, I'm not sure I understand this question quite. What kind of pipette channels are used?
Oh, okay, so maybe the pipetting technology. So they're both essentially air pipetting, which has many different benefits. The Big Tuna uses liquid displaced air pipetting, and on Unagi, on the little guy behind me, that is just straight piston-driven air displaced pipetting technology. But essentially, they're both air displaced pipetting, which means that there's no system fluid that comes in contact with it.
I see. Okay, that makes sense. All right. We've got another question here. How is dilute and filter used?
Oh, somebody was paying close attention. So I didn't go into it for sake of time today, but that is a feature on both instruments where you can the system will do a dilution for you. And the reason why you want to do that, going back to flow rates and sample viscosity, heavy sample concentrations, is if you have high concentration samples, again, those might take a little while to run. So by doing the pre-dilution, which is all automatic in the software, it's a click of a button, it will dilute your sample initially to get the buffer exchange going very quickly.
I see. And are there certain samples that you've seen that people use that more commonly for?
High concentration protein samples.
That makes sense. Okay, all right. Question here that came in. Oh, pretty complicated, pretty specific question, so I'll try to read this out verbatim.
I will pay attention.
Okay. What is the recovery rate for low concentration samples so this looks like 100 to 300 micrograms and 200 microliters. So I guess that works out to half a mg per mil up to about 1.5 mgs per mil for a 96 well plate.
Okay, yeah, good question. Obviously, like if you look at the specs for it, we take standard, I think it's IgG that we sort of published the specifications to, but it is true that with your samples you may have different results. So what I've seen, I don't know about your specific samples, but I've seen with other customers who've used Big Tuna and Unagi with proteins, typically or monoclonal antibodies in that concentration range, is they're still getting, I would say I've seen from like high 80s to like low 90% recovery rates. So maybe not exactly 96%, but better than what has been reported to us, at least when they run it on their centrifuge spin columns.
Gotcha. Okay, cool. All right. Actually, we've got 2 questions that are about the same thing, so I'll just answer the first one. Basically, just answer this one. Does Unagi only have one molecular weight cutoff for its membrane, or does it have multiple?
Sorry if I didn't explain that clearly. It has multiple. It has a 10, 30, and 100 kilodalton molecular weight cutoff, and that's in the regenerated cellulose flavor.
Gotcha.
So it's the same membranes currently between both. You can get it in the 24, 96, and the UNA, the 10, 30, and 100 molecular weight cutoff. The 3 molecular weight cutoff is currently only available in the unfiltered 96.
Cool. And then actually there was a follow-up question to this. Well, I mean, I think you've answered that question. They were also asking if there's any plans to provide a 100 kilodalton molecular weight cutoff for UNA, but it sounds like we've already got that.
Yeah.
Fantastic.
Operators are standing by, so call now to order.
And then one last question that I think actually is interesting. Maybe we can talk about that sometime later. Can you set up a run to get to a specific concentration? So I guess could a user put into the software, I've got a concentration of 1 mg per mil, I want it to end at 10 mgs per mil?
Yes, absolutely. The way that we do that is by the volume. And so, although you can enter in like your starting, micrograms per mil or capsids per whatever the units are for AAV.
VG per mil usually, or capsids per mil.
Thank you, Dr. Walton. Yeah, so you could put the units in and the initial concentration value for every single sample, and that's for all 96 or just one UNA. And that's used for reporting features. And really the way that we do our concentration on both platforms is more by the volume. So let's say you know your starting concentration, and if you need help with that, we have other products like Stunner and Lunatic, which can help you there. But if you have the starting concentration, it's really just the final volume that you want it to have to go to. So can you get it to your specific concentration? Yes, just pull up your little calculator, do a quick calculation, you'll know what that final volume should be.
Gotcha. Very cool. Okay, and then, for Big Tuna, can we only use 4 or 5 wells at a time?
No, and if we're talking about, let me sneak in here and grab this. If you're talking about on the unfilter, you can use any combination of wells, so you can use all 24 or 96 if you want. And if you meant for the reservoirs, which are on deck, that's all calculated by what you put in terms of like your target buffer exchange cycle, and really like that's going to determine the volume in addition to the number of samples and the volume of samples, the volume of the buffer that you need on Big Tuna.
Cool. All right. Okay, so it looks like we got all of the questions that have come in answered, so I think we're going to go ahead and wrap up this live demo.
Aww.
I know. Well, maybe, you know what, if you guys have any other questions or anything else that you'd like to reach Dell about, what's the best way that they could get in touch with you?
Support@unchainedlabs.com.
Fantastic. All right, well, thanks everybody for joining us. Thank you, Dell, and we'll see everybody next time.
Thanks. Bye.